Thank you for the introduction and having me here. It's a pleasure and a very nice setting. Unfortunately, the talk is not going to be in Spanish. I know the previous ones were in Spanish, but it's hard for me, so I'm going to make it in English. Tell me if there's anything you don't understand throughout the talk. I have an accent and my English is not perfect, but we will try to go over several parts in this talk. And I'll start by talking more at a high level about how to handle AI in the case of Latin America by using what we can see in other countries and what techniques have been leveraged. Then we'll jump onto the fun parts, which is going to be more technical, with some recapitulation of machine learning and case studies. And then I'll conclude at the very end. Does that sound good? Okay, let's go. It's supposed to be very interactive, so don't hesitate to stop me. One thing I wanted to start with is looking at this graph. So what is this graph? On this graph, you have 3 lines. Each of them represent the growth of number of papers published in a certain area. The blue one is AI. So you see that the growth of published papers in AI since before 2000s to approximately today has been growing very quickly. It's been growing faster than computer science. This one is computer science. And this one is all papers. Computer science going fast, AI is going faster. What is interesting to note is that why is AI going faster than computer science? Intuitively, AI comes on top of computer science, and most computer scientists publish AI papers. What's interesting to see here is that the growth has been outpaced by AI, and if you look into who are the people publishing these papers, you will see that most of AI papers are published by non-computer scientists. They're published by mechanical engineers. They're published by physics engineers. They're published by material science. They're published by astrophysics, which is quite impressive. And what we can deduce here is that AI is not a domain like mechanics. AI is a technological layer that comes on top of a lot of engineering fields. My class at Stanford, 2/3 of the students are not computer scientists, which is very new for the computer science department. It's a graduate class in the computer science department. So this is interesting to note. Another thing that I wanted to talk about is oftentimes when a country would say we invest in AI, when an institution say we're going to take a lot of money and put it in AI, it's very broad and hard to understand. AI as a technological field, you need to understand where you want to implement AI. So I want to spend some time talking about why it's very important to focus on key areas if you want to kickstart an AI program at a large scale. The second topic I want to talk about is regulating strategically, because AI systems have had a hard time being pushed in the industry because of regulations, and it happened with many technologies. And finally, educate massively. When you have, just as when electricity came and the world had to train a lot of electrical engineers, today we probably need a lot of data scientists. We need a lot of machine learning engineers and of course software engineers as well. So we're going to chat about that as well. So focusing on key areas. If you look at the big growth of AI in the industry, you think probably 2011, 2012. And what comes to mind when you think of the first product that really showed us that AI was important? Any ideas? Image processing, something else? Social medias? I think one important one is also, so these are good ones, speech recognition. When we saw the impressive results of Apple, Google, Amazon, Baidu, all these companies that put speech recognition products out there and work it tremendously well, it impressed the population. And so Andrew Ng has been a person thinking a lot about how to push AI in a company, because it was not that easy to convince Google at a large scale in Google that neural networks are a type of algorithm that have to be used for many teams. And so he started with speech recognition because he thought that this is a project that is not infeasible. It's not as hard as building a humanoid or general intelligence or even self-driving cars. It is a project that is probably doable in a not too long year span, and also it is an impactful project that you can see the results from. So from there on, he built a speech recognition system with his team, and this spread out very quickly inside Google. Very quickly, many teams wanted to implement neural networks. And the spread happened because of this vision of it's working. So 3 areas I'm going to focus on and explain why these are also good areas to start with in a country like Colombia or in Latin America in general. The first one is healthcare. So look at this picture here. This picture is a chest X-ray. Okay, so sometimes you go to the doctor and they ask you to take an X-ray. So this is it. And in fact, you can build a model, and it's been the work of Pranav Rajpurkar, Jeremy Irvine, and their team at Stanford called Chexnet, where they built a model that runs also on a device like this phone, and you can take a picture of the X-ray, and it gives you a pre-diagnosis. Do you have pneumonia or not? Tells you several pathologies as well. So why is this very interesting? It's very interesting because it's not a project that is infeasible like humanoids. You can build it in a short time span, and it has a huge impact. Many countries around the world and regions around the world are in shortages of doctors, as you know. So what do you do when you don't have a doctor? You can put a machine to take an X-ray without a doctor. You can have a facilitator on site that helps patient take pictures with these machines. And the patient can get a first diagnosis with that type of algorithm. It's not meant to replace doctors. It's meant to give a pre-diagnosis in places with shortages of doctors. And if it's in the case that the algorithm sees a pathology, you can send it to a doctor and escalate to the doctors. That makes sense? So other projects like that, and these are Stanford projects, cardiologist level arrhythmia detection. When you have heart problems, oftentimes you would be monitored by a pacemaker that you put here. This pacemaker is going to take thousands and thousands of measurements every day, every week. It's impossible for a doctor to go over thousands of measurements for every patient, right? It's very hard. So this algorithm is an example of algorithm that boosts the productivity of doctors by telling the doctor, out of these thousands of measurements, here is where you should look for. These Monday 5 p.m., this is where it seems that there is a heart failure or something like that. So this boosts the productivity. Not meant to replace, it's meant to boost. Another one is palliative care or dermatologist level classification, when you take a picture of your skin to detect if there is a sign of cancer or not. These are very impactful projects. And when you see something like that working, it pushes the spread of neural network in the entire laboratory or in the entire school for people to work on other projects. It's very hard to spread technological advances, but this is how it's possible to make it happen. Another very important topic is agriculture and energy. And you know that in farming, with the new technologies using AI with autonomous machines, you can provide more output from the same land. So if in year 2017 your land gave you X, using a detector of defectuous crops, you can get 1.2x maybe next year. Some countries have a huge part of their economy relying on agriculture. So this is a very high-stake project as well. Some of my students have worked on predictive maintenance for water pumps in Tanzania. This is also very interesting, because if you can predict the failure of a water pump in a country like Tanzania, you can send someone to repair it before it fails, to maintain it. And it's very important. A failure of a water pump is really not a good thing for the population. And this is not as hard as building an autonomous car. So if you had to choose, in Colombia, for example, to build an autonomous driving company and take several years before being able even to test the product, versus this to spread the knowledge of AI and excite the community to build more knowledge around it, I think this is a way that is possibly the way to go. And it's not impossible. So this is another project here from some of my students at Stanford. In 10 weeks, they built a classifier called LeafNet, and you can take a picture of a leaf, and it tells you exactly which variety of leaves it is. So it's an interesting project, and 10 weeks only. So that's why I'm showing it. It's not a year-long project. It's only 10 weeks, 3 students. So with the right mentorship, that's really doable. And of course, manufacturing. Manufacturing is one of the key areas where Professor Eng focuses on with deeplearning.ai, and specifically automated visual inspection. So this is something that doesn't look sexy, right? Manufacturing. It's not sexy, but it actually touches a lot of us. So everyone here probably has a device that contains something that comes from a manufacturing company in Taiwan or in China, right? So a small cost advance on that impacts largely the society. Another thing to think of is how many employees do you think manufacturing giants in Taiwan have? Like one company. How many employees? Foxconn, millions. So more than 1 million employees in the same company. So if you manage to facilitate the work of a small part of these people, it's a huge advance for hundreds of thousands of people, right? The second part I wanted to talk about is regulate strategically. So why is this very important? The first reason is technological regulations matter. We don't want to put a self-driving car out there totally free without checking it before, right? It's impossible. But on the other hand, how do we do to let a self-driving car drive? Should we do like humans where we have a license? So when you take a license as a human, how do you do? You go 30 minutes maybe, sometimes less, and you drive with a monitor sitting next to you, right? The monitor, the instructor, let's say, is making a fundamental important assumption, is that if you're able to drive for 20 minutes in the city and then take an exit on the highway and come back, I think you will generalize. I think I can let you drive in other places, right? I won't ask you to drive all around Colombia before giving you the license for Colombia. But now, let's talk about self-driving. If you see a self-driving car riding for 20 minutes in the city, 10 minutes on the highway, and coming back, do you let this self-driving car drive for free? No. You want to see this self-driving car going in tunnels. You want to see it going in snow, underwater, anything, right? So it's much more complex. It's a debate to have this regulation. What is the self-driving car license? You know? And one thing that I want to stress is that these debates are very, very important. 61% of digital health companies which starts in B2C, so business to customer, end up flipping into B2B, selling to hospitals, to insurance companies, and to healthcare providers. So why does that happen? It happens because oftentimes the regulations don't let them put their products in the hand of customers. So if you cannot put it in the hands of customers, you go through a proxy. You go through someone who's in the regulation space. You work with hospitals hand in hand, and they're going to put it in the hands of customers. But it makes the startup life harder, right? You've learned, and I know the previous talk was on cryptocurrencies and blockchain. The first thing that blockchain entrepreneurs tell you when you ask them, why did you fail, for those who failed, is regulations. We had a great product, great traction. We couldn't put our product out there because they wouldn't let us. And it's fine, it's normal to have regulation. It's just the debate has to happen. And cryptocurrencies, I think, is one space where it hit us so quickly that the regulations didn't follow. So there wasn't that debate that was needed. And that's the case when technologies grow so quickly. So I talked about self-driving car. Another interesting thing to note is, let's look at this video from Kurakin Goodfellow and Sami Bengio here. So you have two types of pictures here which are the same. They represent a library. The difference is that the one here is a picture of a library, and here is the same picture, but if you look from very closely, some pixels have been modified. So let's look what happens when the model looks at these pictures. So this model says it's a library with 71% probability, and here it's a prison with 52% probability. Library is not a prison. So let's look at the second example. So here is a washing machine. And you can see that the pixels are modified here. So the first one is a washer with 54% probability, according to the classifier. And here it's a doormat with 35% probability. Okay, so why is this interesting? Think about a stop sign and a self-driving car. We have a stop sign, we add a few pixels, we convert it in a 50 kilometers per hour, the car can go. It's called an adversarial attack, and it's one of the challenges of regulations for neural networks. Now, another part is favorizing public and private collaboration. All the projects I showed for the healthcare previously, the dermatologist, cardiologist, radiologist projects, they're all the fruit of collaborations between hospitals and laboratories of computer science and machine learning. And this could never have happened. If there was not a computer scientist sitting next to a radiologist to chat all the time and ask for pointers, these projects wouldn't have worked. So Stanford laboratory has the chance to have the hospital right next door and the med school next door. So it facilitates that, but it should be the case in more universities, I think. So yeah, and a good ML team, I would say, is an ML expert and a subject matter expert. Sorry. Finally, educate masses. So this is a statistic from the UNESCO Institute of Statistics in 2014, saying that 27.3 million primary school teachers need to be trained and recruited by 2030. This is a huge number. So how can we achieve that? It's very complicated. So I think one thing is to challenge this education statistic is reducing the mismatch between job seekers and job openings. I come from a country where we usually train a lot more physical educators than there are jobs for physical educators at the end of the programs. So we can easily say to half of the physical educators, approximately, that they're not going to find a job in physical education because there's no space. And of course, you're not going to force someone who wants to be a physical educator to not be a physical educator. But there needs to be transparency. They didn't know when they went to physical education that the job market looks like that. So there needs to be information on what's the mismatch between the job market and the education in universities. That's a big problem in many countries. Another one is for companies to sponsor online content. So this is being democratized more and more in the United States. Companies, when they hire someone, give them access to open courses online and sponsor all their credits for online learning. And this is very important. 1/3 of computer scientists today say that they never had a computer science academic training. They learned everything online. It's very common for computer science. At deeplearning.ai, we focus on artificial intelligence courses online, but on Coursera, you can find virtually any engineering topics. For universities, one thing we've tried at Stanford that's been going quite well so far is the flipped classroom format, where we noticed that instead of training instructors, we can train facilitators. It takes a lot less time to train a facilitator that can help the students on a daily basis, rather than training instructors all around the world to teach all the time. So leveraging the time of an instructor, and that's what Andrew Ng has been doing with videos online, and combining that with on-site learning with facilitators helping students is very important, and it's the only way to scale all this knowledge of instructors. So today, every quarter, we have 8 to 15 teaching assistants and facilitators that help bridge the gap of knowledge between the instructor and the students at Stanford. And that allows you to have more than 1,000 students every year in our course, on-site. The last one is leverage out-of-the-box AI. And I think I've seen in this conference talking a lot about Django, Flask, all these frameworks that come on top of Python. Deep learning has their own frameworks, and you probably know them. And today, if you want to build a deep learning model, you don't need to be an extremely good coder. You can leverage this deep learning framework. And this is a way to define a model in a few lines of code using Keras from François Chollet. So there you define the model, here you compile the model, and there you train the model. And it's interesting because 10 years ago, this thing was an entire function to code. This thing was an entire function to code, and this one was also an entire function to code. Now it's everything in one line. So it's very cool. The reason I want to say that is because now we're going to focus on, in the next part of the talk, on what is important to know in machine learning? It's oftentimes not the code or the math behind it. It's the decision process of structuring a machine learning project. So that's what we're going to delve into. Now, we talk about all that, but what's hot right now is neural networks. So why neural networks? If you look at this graph, which is the number of AI papers published on Scopus by subcategories, neural networks, computer vision, search and optimization, and NLP, and so on, you see that the main drivers of all this research in AI is neural networks and computer vision with machine learning. So it's very interesting that this type of algorithm has been leading a lot of research. And the reason is it's a great function approximator. You know linear regression, right? Linear regression is a good function, but it cannot model very complex things, like detecting a cat, for example. Neural networks are able to model that type of things. So among AI algorithms, neural networks play a very important part right now, and we're going to do a technical recap on machine learning. So now starts the fun part, I would say, with some techniques. So who has worked with machine learning before here in the room? Okay, a lot of people. So let's look at what's the general setting of machine learning. Here I have a very cute cat. It's my input. What I want is to build a model such that the model tells me 0 if there is no cat on the image, and 1 if there is a cat on the image. It's a classification problem. Okay, so first we need to define what a model is. And the way I like to define it is it's an architecture plus a parameter. So to think about the line of linear regression. What is a line? It's y equals ax plus b. This is the architecture, it's the line. What are the parameters? They're a and b, slope and intercept, because they define how the line should be. They cannot make this line become a circle. They can just use the architecture and tell us which line it should be. Neural network is the same thing, but much more complicated. It's not a line. It can fit very complex functions, but it's the same. Architecture is a neural network, and parameters, instead of 2 parameters, it's millions and millions of parameters. You need to have millions of parameters to model the complexity of a data set like a cat detection data set. So we send our cat, and we get 0 as an output. It means the model is very bad. It's not detecting the cat. We want this to be a 1. So we're going to compute something called the loss function. Who's familiar with the loss function? Loss function is typically an objective function. You want it to define how good your model is. So the way we will define it is, we will define it by the distance between the prediction and the ground truth. The truth is 1 here. It's a cat. The prediction is 0, so we have a distance of 1. And we want to bring this distance down, right? And we want to do that for many cats. So I send my cat, I get 0, I compute my distance between 0 and 1, the ground truth, and I will use gradients to change my parameters. So now I modify my parameters. I shift them a little bit. I move these numbers. Then I send again my cat, and maybe next time it's going to be 0.2, because I moved my parameters. And I do that with another cat. I do that with a picture of not cat, and so on, until my parameters are such that this function, the loss function, is minimum. The distance between prediction and ground truth is small. And that's how I get my model. Okay, so we can do that many, many times. And this is my favorite visualization. It took a year for me to learn that. Okay, so now we updated our parameters and we get our model. In machine learning, many things can change in these models. One thing is the input, right? The input can be an image, it can be a text, like machine translation. Take one language from a text, translate in another language. It can be a speech. You've seen many speech synthesis, products. It can be also structured data, like a table on Excel. So you have to be able to play with all of that. The output is also different. I could have told you this problem is find the age of the cat. It would be a regression problem. It's not a classification anymore. I could have said let's look at the breed of the cat, which is a multi-class classification. It's not 0 or 1. It's 0, 1, 2, 3, 4, defining the classes. Does that make sense? Architecture can change, neural networks, convolutional neural networks, any other machine learning model. And the loss function, the distance can change as well. We're not going to go to the details of that. So now that we have this baseline of technical recap, I want to delve into 2 technical studies. And the goal is to present that what is important in those projects is the decision making. It's not the code too much. You will have to code it, but the decision making is what makes a machine learning project successful. So let's look at these 2 games. First, day and night classification. So the goal is, given an image, classify it as taken during the day or taken during the night. Okay? So first question, and we will play together so that it becomes interactive. What data set do you need to gather? Images? Images of what? Cats. I heard cats. Outdoor images, day and night. And you probably want it to be balanced, right? Because you don't want only night images, you want a balance between both. Okay. So let's look at 10,000 images. Do you think it's a good number? How did I come up with this number? Who thinks it's too much? Who thinks it's too few? Okay, more people think it's too few, actually. I think it's a good number. So how do you know if it's a good number? First, you look at projects that you've already done. So we've already done a cat classification project, just in the previous slide. So let's say we had 20,000 images on this cat classification project, and we did very well. How do you compare this project to the previous one? Easier or harder? Who thinks it's easier? Who thinks it's harder? Oh, balanced. I think it's a debate, but it's probably easier because cats are sneaky, they can hide, right? You can have a cat in the corner of an image, right? So it's probably easier. And 10,000 images, I think, is a good number because we know that 20,000 images has worked very well for cats. Now there's a debate to have on that because depending on how you define your project, it can become much more complex. Can someone give me an example? In this case of day and night. Sunset, sunrise, morning. So these transitions between day and night are very hard for the model. So maybe we need to give a lot of these images as well. Another example. Lighting? Light inside. So how about an indoor picture? Like, you know, it's interesting because for humans, if I take an indoor picture, if I ask you, you're in my spot, and I tell you, is it a day or night picture? How do you do? Can someone tell me if it's day or night? So one way is if we have a window on one corner, maybe. And humans have the idea to look at the window. The model doesn't. Right. And I will talk about that a little later. But okay, we see the window, we see a light or no light, and we can tell. If we want the model to do this, we need a lot more than 10,000 images, probably. It's much more complex. How about the hour? I can look at the clock, if there's a clock, and figure out if it's day and night, relying on the clock, right? But the model is not going to find out. Like, it's super hard. So depending on how you define your projects, you need to decide how many images you need to collect. Now, coming back on the intuition of the human versus the model, there is a game called Montezuma Revenge. It's a very complex game to play, but a human can play it very easily because it's a game where you have to control a small character and you have to go right and left, but there are objects everywhere, like table, like a ladder, for example. As a human, when I see a ladder in a video game, I know I can go up. Like, I'm used to it. I know a ladder, I can go up. For a model looking at the screen, doesn't have the context that a ladder is used to go up and down. It's much more complex for a model to learn the fact that you can go up the ladder than for a human. Here's the same for images on windows and clocks. What should be the split? 50-50 probably, and we don't want to have too much light image. This is a picture of the Louvre Museum here. And sometimes you have the question of what resolution should we choose. What's interesting is that a large resolution gives us a lot of information about the image, but on the other hand, what it hinders is that it needs a lot of computation power to process all these resolution. So what I would do is, quickly, I would print this image in different resolution, 10 by 10, 50 by 50, and 100 by 100, and I would go show it to a few people to see if humans are able to find if it's day or night based on that resolution. I will choose the minimum resolution that allows the maximum accuracy for humans. 64 by 64 by 3, because it's a RGB picture, seems good. What's the output of the model? 0 or 1, day or night. What's the last activation of the model? Softmax or sigmoid, probably sigmoid. I won't go into the details, but it's a function that takes your number and puts it between 0 and 1, so that it's a probability. Architecture, probably a shallow neural network, should do the job very well. And the loss function is going to be a binary cross-entropy loss. This is a distance function comparing our prediction to our ground truth. Okay, just as a simple distance, I'm not going to go into the details of that function. So this was our warm-up. Now, what's interesting is this new problem. Given a 10-second audio speech, find the word activate. It's called keyword spotting, and it's very similar to Alexa, Ni hao Baidu, OK Google. You know these problems, right? Hey Siri. We want to detect only one word. We don't want to detect other words. So how do we go about that? What data? Images. The same guy who said cat. Oh yeah, I heard it. We need a bunch of 10 seconds audio clips, right? And the distribution of these audio clips, it should be very wide. We need to have girls and boys. We need to have young people and old people. We all have different frequencies, right? We need to have all types of accents in the world. And you also need to have both positive words, activate, and negative words. Kitchen, lion, cerveza, or whatever. You can choose. Negative words. So the input would look like that. A clip, which is 10 seconds, and there is some positive words, like activate, and some negative words, the ones I cited. Now, what should be the sample rate? If you're not an expert in speech recognition, it's hard to know what should be the sample rate of my microphone to have the best accuracy for my model. So what you do in that case is two choices. Either you talk to an expert. So I remember when I implemented this project with Professor Eng and Younes Bensouda-Mouri, I talked very frequently to one friend that was an expert in speech recognition outside AI. And I told him, what's the main sample rate you've been using to process your speech? He told me, go on my GitHub, look at this project, take all my hyperparameters. And it saved me a long, long time, probably, rather than finding it on my own with experimentation. Output. What should be the output of our model? 0 or 1? Y equals 0 or y equal 1? 0 for no activate, 1 for activate. So now let's play a game. We're going to do an experiment. Here we have 3 audio clips, 1, 2, 3. And the labels are the following: y equal 1, y equal 0, y equal 1. What I want you to do is think you're a machine learning model. You're not a human. You're a machine learning model. And the machine learning model, as I said, doesn't have context of what a ladder is looking at the window. So the only thing it's seeing is an audio wave, which is a sequence of numbers, and a label, 1 or 0. So now, there is a trigger word that is not activate. I want you to find the trigger word. Let's go.
Maria, è ora di andare a scuola. Ti passo a prendere questo pomeriggio.
And of course, it's not in Spanish. Let's say the second one.
Ho giocato a calcio sabato sera con gli amici. È stato divertente, ma abbiamo perso. Che cosa fai questo pomeriggio? Potrei andare a fare shopping oppure vado a fare la spesa.
Who has the trigger word? Miesa? No. Shopping? No. Cerveza? No. So now let's flip the experiment. Nobody got the word. Let's flip the experiment, and what I want to stress is that the strategy behind the machine learning project is what matters. So let's go with this labeling here. Same exercise.
Maria, è ora di andare a scuola. Ti passo a prendere questo pomeriggio. Ho giocato a calcio sabato sera con gli amici. È stato divertente, ma abbiamo perso. Che cosa fai questo pomeriggio? Potrei andare a fare shopping oppure vado a fare la spesa.
So what's the word? Pomeriggio. What does it mean? It means afternoon in Italian. So here is the experiment. what it shows us is that you can decide to follow this labeling scheme. You will need probably 100 times more data than if you use this labeling scheme. 1,000 times. You probably will never find out. Does it make sense? So this is an experiment to keep in mind when you structure your data projects. Now, let's go back to our problem, but we're going to replace this, of course, by this. Identifying where the word is. It's easier for the model. One downside of this labeling is that there are much more zeros than ones. So your model can predict only zeros all the time, and you will get 99.9% accuracy. You can push your model online. Nobody's going to get detected. So what we do is that we put more ones. We just expand the number of ones for every positive word. Okay? What's the last activation of the model? Sigmoid, but sequential for every time step. You want a probability between 0 and 1. What's the loss function and the architecture? Architecture probably should be a recurrent neural networks, because in speech and natural language, you need memory. You need to understand the context. And this is the type of network that understand long-term dependencies. You could use a convolutional neural networks as well, probably here. The loss function, same as before, but sequential. One interesting thing that I noted when I worked on that project is the first version of the model. I trained it, and very good. I was super happy with my training. I looked at the model performing on the test set, real-world data. And then I saw that there are 10 examples in the test set that the model doesn't detect at all. And I looked into them, and it was all my German friends. So all my German friends were not getting detected. And I learned that by doing error analysis, analyzing my errors. So what I did is that I took my phone and I gave a call to a couple of German friends and told them, can you send me words of activate and other words? Put it back in the data set, and now we're good. Okay? So this is called error analysis, very common process. So two things that I want to stress to finish that were critical for the success of this project. The first one is something that AI companies have been doing very well. This is one characteristic that defines what an AI company is. Strategic data collection and labeling process. So let's see what it is. If you had to collect this data set, how would you do? No idea? Someone wants to try? Okay, so let me give you a hint. One way is to use a mechanical Turk. You know what it is? So you put a task that you code on the cloud, and people around the world can do the task. It's very common for data processing. What does it hinder? It's like the problem is, if we do a mechanical Turk, people around the world don't have microphones on them all the time when they try to take tasks on mechanical Turk. They probably don't know even how to open the microphone on their computer, so you need to make everything easier for them. Right. So if we wanted to build a mechanical Turk, the right way would be, we take a week and we build a web application where there is a counter saying 3, 2, 1, say this word, you say it, then it stops, and then it sends it to the database, for example. That would be good. But it would take us 1 week to build, and we're on tight deadlines. We have 5 more minutes. So that's not what we did. What we did is, so I used an app called TaskRabbit, and on TaskRabbit you can hire people to come and help you with whatever tasks you have. So Younes and I, we had someone come, and we gave them one phone. And the 3 of us went around Stanford campus to ask for words. Okay, but the way we did it is, we didn't ask, give us a 10-second audio speech. So I wouldn't go and say, give me 4 words, and one of them should be activate in this 10-second audio clip. That would be a pain to label. So instead, what we did is we created 3 databases. The first one is positive words, only activates. The second one is negative words, only other words, non-activates. And the last one is background noise. Why did we do that? First, because background noise is very cheap. You can go online, scrape background noise on virtually any video, as soon as the license authorizes it, right? So we have tons of background noises. Noise in metro, noise in city, noise in libraries, and so on. That's enough. Positive words. What we do, instead of asking for 10-second audio clips, we record only words per word. So every time I would go with my microphone, I would say activate. The person would say, activate, so on. And then I would say cerveza, and they would say cerveza, and I would cut it. Okay? I would put all the activates in the green database and all the others into the purple database. Then I will take a background noise of 10 seconds, and I will insert a positive or negative word at different positions. Okay? Why is that critical? So you have a recurrent neural network, but that would be the case with the 10-second audio clip that is not synthesized as well. So why is this synthesis very important? What is the critical part of that? It's the labeling. I know where I inserted my positive word. I can just label at the same time, automatically. I can generate millions of data points from 20 words and label them automatically. So that's the power of strategic data acquisition compared to someone who would go and get 10-second audio clips, go back home and label them by hand. You see the big difference? And of course, in order to test your model on the real world data, you cannot test it on this. You will have to collect some small part of your data, 10 seconds full audio, and then label it, because this will look like real world, not this one. But with new methods of speech synthesis, this looks very well like real world. So that's one thing that is very important, and you can label it when inserting the positive word. Automated labeling. The second one is architecture search. Many machine learning projects need architecture search. And so if I tell you my story, is I tried very hard to solve this problem, and it didn't work for a long time. So what I did is that I took my speech, I sent it in a Fourier transform, which is basically taking out some frequencies and amplitudes in sine functions from this sequence of numbers. Then I send it into an LSTM network, which is a recurrent neural network. I sent it into my sigmoid, which will give me my probabilities. And I compared that to the ground truth, and I trained my model. Wasn't working at all. I spent several days trying to fit a model, didn't work. Then I was walking in the Stanford corridor, and by chance, I meet a person, Oni Anun, who has experience in speech recognition plus AI. So I told him my problem, and he identified very quickly what was going wrong. He first told me, your sequence is too large. It's very hard to train a model with that much numbers in a sequence. You need to reduce it. One way to reduce a sequence that comes out of the Fourier transform is to use a convolutional neural network, because it's going to reduce your sequence. So now I'm working with less numbers. Coming back to our discussion about resolution. Coming with less numbers, but it's easier to train my model. The downside is the time at which I detect the word activate is not going to be as precise as before, because my resolution is lower. It doesn't matter. I don't need to detect activate at a millisecond. It's fine. So then he told me, you need a batch norm layer to help training. It's another type of layer in neural networks. And you need to use a GRU instead of an LSTM, which is another type of architectures. So all in all, what I did is that I used that, I trained it on smaller number on my sequence, and then I expanded my sequence by just doing a simple interpolation. It worked much better. So why do I say that? It's just to illustrate that in machine learning projects, instead of spending too much time trying to find the right architecture, oftentimes is look at the paper, contact the author, ask them about their point of view on your project. Usually they're happy to help. Or try to find the expert. It's better to spend a full day emailing a bunch of experts and hoping that one of them gets back to us than spending a full day experimenting with 10 architectures. At least that was my take on this project. So never give up and use error analysis, as I said, with the German accent. So to conclude, I wanted to stress that we've seen some opportunities in different directions for Latin America and different countries. And then we delved into some case studies, and what we should get is that what is important in machine learning often is how to structure your project. The code, you can learn it. The math, you can learn it. But the structure of your project, you have to learn it through pain and projects. Oftentimes, I tell my students who are taking 10 AI classes, you took 10 AI classes, but you know a lot of different algorithms, but what have you done in AI after these 10 classes? And oftentimes, if I compare with a student who has taken fewer classes but has delved into a project and built a vertical on that project end to end, I see that these students have much more experience, actually, because they've been through strategizing their machine learning project. And that's what is very important in the industry. So thanks for having me, and thank you, PyCon. It was great being here, Ison. Many nice talks. I will finish by saying that so deeplearning.ai, AI Fund, Arista, Landing.ai, this cluster of company led by Andrew Eng is now in Medellin. So we opened an office, and the lead of the office is actually here, Alejandro Betancourt, that I will ask to come here. So I think he wants to talk a little bit about how important it is to emphasize an AI community in Colombia. So we're involved in that, and I will let him take over. Thank you very much, everyone.
Gracias, Kian. Muy interesante la presentación. Muchas gracias por invitarme. Sí, yo soy la cabeza de Landing AI Colombia y tenemos una oficina muy interesante en Medellín. Quiero hacer énfasis. ¿Alguien conocía AI Found antes de esta charla? Aquí alce la mano. Bueno, poquitos. Arista. Menos. Deep Learning AI. Bueno. Landing AI. ¿Quién sabe quién es Andrew Ng? De Founder, o conoce Coursera, o sabe quién es Andrew Ng en la comunidad de Machine Learning. Creo que todo el mundo ha oído de cierta forma de Andrew Ng. Y los quiero invitar en serio porque el equipo que estamos consolidando en Medellín es supremamente fuerte y no necesitan tener toda la experiencia en Machine Learning. Estamos buscando, como ven, experiencia en Software Engineer. No necesitan ser los duros en Machine Learning, saber sobre Deep Learning. Si saben de código, los invitamos a que hagan parte, a que apliquen, a que traten de pasar en las entrevistas. Es un equipo supremamente interesante y yo creo que nos están invitando a un baile, que es ser parte de una revolución que está pasando en Latinoamérica a través de inteligencia artificial. Lo que tenemos que querer es bailar, ir al baile y aprender lo que se nos está pidiendo, ¿sí? Entonces los invito en serio a sumarse, a tratar de pasar a nuestro equipo. Y hay alguien del equipo acá también, entonces el domingo él va a estar presentando algo sobre Flask, Sebastián Rodríguez. Entonces los invito también a ir el domingo a la charla de él y le pueden preguntar más sobre la empresa, la cultura de trabajo, todo. Gracias.
Muchas gracias.
Thank you very much for the presentation, Ken. So we will have now like 8 minutes of Q&A, so please raise your hand and we'll approach you. Thanks.
Okay, well, nice to meet you. My name is Ivan Lozano, and I'm coming from San Francisco, actually. I live in the Bay Area. So I have a question for you. If I would like to develop a platform, a neural network to learn how to code from GitHub. Let's say that we want to put some data. I want to say to this neural network, like, hey, go and learn how to write a hello world in Python, or how to connect an Amazon Web Service with something else. What kind of architecture should you use to develop this?
Very hard question. So everybody heard the question, or should I repeat it? Okay, the question is, you want to build a network that would learn how to code based on GitHub code. So we'd probably scrape data on GitHub, create a database, and then use an architecture to output some code. It's like hello world in Python. So first you need to identify, is your output, same thing we did, is your output 0 or 1, or is it something else? You know? Your output is probably a text. So you need some kind of encoder-decoder architecture. You need to encode the codes in a small representation of it, and then decode this representation, just like machine translation. It's going to be very hard for me to tell you, use this architecture, obviously, because I never went there. But one thing that I often do on new project is I use a proxy. So what I would think is, your project is building a coder, neural network coder. What is a proxy project to that project? I think a proxy project can be probably a machine translation project, or probably, maybe at another extent, an image to LaTeX project. You've seen these projects, image to LaTeX. So the first thing I would do is I would go on GitHub and type image to LaTeX, deep learning, neural networks, your favorite deep learning framework, and I would look at all these projects, see what architecture they've been using. I will get it from there. Yeah.
Thank you.
You're welcome.
Yes.
I have two questions. The first one is about community. You say, for example, that in your case, if you had any problem regarding to your architecture, well, in the corridor, there was a colleague who helped you. But in general, moreover, here in Latin America, what are the sources? Where is the community, or which ways do you see to enhance that community? That's the first one, and the second one is, do you know more cleaner data sets or projects trying to build data sets regarding to audio?
Okay. So I will repeat the first question and the second question for everyone in the back. First question is about community. When you don't have the opportunity to be surrounded by, let's say, PhD students, experts in fields, how do you do about getting the information you want on your project? So I think that one thing I do every morning is when I wake up, I open Twitter and I read what many leaders in the AI space are posting. And sometimes I will retweet them. So people who have me as well, they would see my retweets. And this is very important for me because every morning I would get a sense of what are the new projects being done. And in my head, I will build a portfolio of projects that I know where to find. So I probably wouldn't know exactly what the project is about, but I know that next time, if I want to build something like that, this is my proxy. And I will go for it. Or I know when a student is going to enter my office, I'm going to tell the students, oh, I remember this AI leader, AI researcher has posted that, you should check it out. Build your portfolio by following the right leaders in AI, in the AI community, and they're around the world. Another way is, I know I've seen actually some people here from the data science community in Bogota. So I think getting involved with this community is going to help both the community grow as well you build a network of people that know. The third point would be, if you have a paper, you're working on it, email the authors. People don't do it enough. Authors are really happy to receive an email from another part of the world saying, I loved your paper, I want to try to re-implement it, can you help me, can you give me pointers? It will take them 15 minutes to write you an email, but oftentimes they will do it. Yeah. The second question is about building a data set for speech recognition and how do you go? So can you be more precise on this question? Do you have a microphone still or no? Like what kind of speech recognition? There are various speech recognition tasks.
Yeah, the question was, are there any data sets or projects trying to build data sets on speech recognition?
Yeah. Question is, are there any data sets in speech recognition or projects trying to build data sets on speech recognition? Yes, there are plenty of open source data sets on speech recognition. One of them is Timit, I believe. Another one is recently released by Google on commands, like yes, no, left, right, things like that, and trying to classify all those. So there is content online about open source speech recognitions. And the way you can find it is by typing it online, or oftentimes, if you look at classes in many universities, you look what students have been doing as project, and you go over the list, and you find something meaningful oftentimes, just with Control F, speech.
Hi. You mentioned that you need to have a good strategy for making a solution for your problem. Do you have a toolkit or like something very common in those strategies?
A toolkit for these strategies?
Or some general strategy, or where to start, or how to build your strategy, what questions to answer to build a strategy?
Yeah. I have pointers on that. So For example, recently I've been very interested into, and I think it doesn't apply only to AI, I've been very interested in platform businesses. So like, you know, Uber, Airbnb, Rappi, all those are platform businesses that scale very fast. But I've never built a platform business. So how do I do about it? I think one is try to build it, and you will learn on the spot through hard pain, you will learn. Another way is find the books that are talking about war stories. So for example, there's a very good book called Platform Revolution from people who have lived that. And I take 2 weeks to read this book, but it teaches me a lot of insights on what's the strategy to adopt in order to build a platform business. Another one who came out from the co-founder of LinkedIn very recently, a few months ago, Blitzscaling, is another very good book to understand how platform use strategy to grow. And so just reading these 2 books give me the background in my mind of if I want to build a platform business, here are pointers that I need to know. In AI, it's the same thing. I think for these strategies, read papers every day. Read, and you will build that type of intuition on. I remember these guys working on speech recognition, they used a speech synthesizer to generate their data. So now you know it. But by reading a lot more papers, you will learn a lot of war stories from researchers. Or go to talks, look on Google, on YouTube, sorry. Yeah, I don't know if it helps, but.
Kian, thanks for the presentation. I want to know what is the main difference between GRU and LSTM, because you show us a slide when you said that the expert tell you that you have to switch to a GRU rather than an LSTM. When is the use case of pure vanilla RRN? And yeah, what's the main difference, pros and cons? They use one type of network and other.
Okay. Yeah. One more thing I wanted to add to the next question is find the right team to work with in the industry. Because oftentimes these strategies come from working in a team, in an AI team. So like that's one thing you want to do, prepare interviews and find the right team. So circling back on GRUs versus LSTM. So these are 2 cells that are used in recurrent neural networks, LSTM and GRU. It's very hard to know which one is better. You have to experiment it. It's just like when you start a project, how do you choose the architecture? It's very complex. If you plot your data on Excel and you see that the data looks like a line, you probably think I would use linear regression. So this works for lower dimensional problems. For higher dimensional problems, it doesn't work. You cannot plot it very easily. So how do you do? Oftentimes it relies on experience. I cannot say why GRU worked better. I can say that the expert told me after working for a month on that project, he figured out that GRUs were better at understanding the function detect the word activate than LSTMs. Because these are just architectures with parameters moving around. But if the architecture is well structured, it will be easier to find the right parameters. Otras preguntas?
Okay, so we ran out of time for questions. So, okay, last question. Anyone? Last question. Going through once, going twice. So, to the gentleman in the back.
Hello. Yeah, I just want to ask you if you have some experience with generative models, basically in speech recognition, if you want to generate voice based on.
Yeah, interesting. So generative models for speech recognition. I think one of the best work in generative model for speech recognition is WaveNet. Maybe you've heard of it. So WaveNet is a very good text-to-speech model. You give a text as input, it outputs a speech. So I would get this project started by looking at WaveNet. And what I would do is, oftentimes in papers, the first paragraph contains the introduction. And what is the introduction? Usually it's listing what has been done in the field and citing. So in the introduction, you can feel a very good summary of where the field is. So I would go on WaveNet, I would look at the introduction, I would read the papers corresponding cited in that introduction to get a sense of how people have been working for generative models for speech. Yeah. Otherwise, yeah, generating models for images is very different from that, and generating text is also very different. Yeah. But I don't know if you were asking for that as well.